So hi everyone. Today I'm gonna discuss about weekly contest 297, and let's just quickly get started. So in the first problem we are given a 2D array bracket where bracket of I is equals to upper of I and percentage I, and basically what we have to calculate is the total amount of taxes are paid when we have total income. Income is also given. So yeah, so in this problem what we are given is you have like an array of type 1 comma, let's say 10, and 3 comma, let's say 20, and let's say we are given in some income x, income x. So what we have to calculate is the total amount of taxes we have to pay if we have total income is equals to x. So for like for money value 1 we have to pay 10% of tax. So if we calculate tax is equals to 1 into 10 upon 100, and for like for next two amount, like for next 2 rupee you can say we have to pay 20%. So for two next 2 rupee, you have to pay uh, like 2 into at the rate of 20 this month. So yeah, you just have to calculate this and print the answer. So let me just show you my solution. So what I was doing is I am taking like double of answer, and here input represent the total, like the total for total income which we have calculated the answer. So like in here represent, like if I have calculated answer for 1, then in is equals to 1, and if we have calculated for whole of this, then in is equals to 3. So yeah, so what we gonna do is the maximum amount of income for this interval, what we can do is we can calculate like the amount of like the income we have. So the income which we have is like this value minus previously taken, and so previously taken is stored in, and the current is we will like iterate over the array, and this is like the current amount. And what we are taking income minus 1 is basically like if we have amount like 10 and date is 20, and we have total income, let's say total income is equals to 8, and we have already taken like we have already taken like 6. Let's suppose we have already calculated answer for 6 rupee. So here we only have to calculate for 10 minus 6 means 4 rupee. So by doing this I am calculating this amount, and like minimum of these two, and then I have just calculated the answer, and I have plus like current value and then return the answer. So yeah, it's a simple problem. So let's just move to the second problem. So like it is quite difficult for, initially for me to understand what this move of cost of I j means. So yeah, so in this problem we are given an grid of m into n. So and like for and move of cost of I comma j. So the value in grid m into n can take value from only m into n minus 1. So yeah, so in this grid we have all the distinct values, and the value can only take place from m into n minus from 1 0 to m into n minus 1. So and all of these values are distinct, and like if you jump from this index, like if you jump from 0th to any of the, you can jump to any of like next row. So you can jump from 3 to 4, or you can jump 3 to 0 at the cost of, like suppose this is 0 1 2 and 3. So 3, and you can jump to zeroth column of next row. So what I was basically trying to say is that you can jump from, like you can jump from this column to any of the next column. So if the current value in this column is well, so what I am trying to say is that you can move from move cost, let's suppose like move cost of value, move cost of value, like the value present, and to the column we are jumping. So you can only jump one row, like you cannot jump like here. So this operation is not allowed, and you can jump to any of the columns in the next row. So uh, so what I have done is I have used the dynamic programming approach here. So let me just tell you like where the greedy will fail. So let me just quickly show you the case where greedy will fail. So greedy will fail when, like for a greedy approach, what we can do is for every row we will calculate like the minimum of all these edges, like so all these edges has minimum like 3. So the cost will be 5 plus 3, and then we have minimum is like connected to this one is 8. So in this case it will give, I think, the optimal answer, but it will, it can fail. Suppose I have something like this, and suppose we have something like 1 2 3 4 5 6, and cost from here is suppose 1, but cost from here to everywhere is like a very large number. So cost is very large, very large. So these are the cases in which the greedy approach will definitely fail. So that's why I have used like the dynamic programming approach. So yeah, so I just like taken DP and like initialize it with Intermax, and what I have done here is so uh, it's just some debugging part. So yeah, so in this, so like I have iterated over the whole grid, and I have then I have I have visited all the columns of previous. So if I am in this row, then I had visited all the previous previous columns of previous row, and here dp dp of I comma j. So basically here dp of I comma j represent the minimum cost to reach this index. So what I am trying to say is that so let me just write it quickly. So AP of I comma j represent total cost to reach ij of grade. So yeah, so if we are standing at zeroth row, so if we are at this row, so the cost simply will be like the values of these row columns. So yeah, for this, if I is equals to 0, then the value will be grade of I comma j, and else the value will be minimum of like the current value, and like we can come from so like what this part represented. So this part basically represented like suppose we are coming from so if we want to calculate for 4, then we can come from 1, and we can also come from 2. So we will try to calculate all the values, and then we just take minimum of all the values, then the cost, then the answer for this index will be minimum of previous calculated values. So what I am trying to say is that we calculate, suppose we had come to 4. So we had come to 4, and we can come to 4 from all the previous row column. So we can come to 4 from 1 and 2. So if suppose we have some answer x for first value, then for 4 what we will have is like this answer plus this value x plus 4 plus this move cost. So yeah, so this is like for previous, like for this we have dp of I minus 1 j, then we have mp of grid of I comma j comma k. This basically represent like the move cost. So from here to here, what is the move cost, and then this grid of I comma j represent this value to the column which we are moving to, and in the last what we can calculate it like the minimum of like if we have reached, so if we have reached the last, suppose we have reached the last, so we can calculate the minimum of all these columns, and that will be the our answer. So that's the solution from problem minimum cost and rate. So just move to the problem. Yeah, I found like minimum par cost and rate like is, I think, is more difficult than fair distribution of cookies. I don't know why, but yeah, this is like a very standard kind of problem. So yeah, so but some missions like I cannot say. So you are given so in this problem, what we are given is we are given an integer array keys, and where key of I denotes the number of cookies in the ith bag, and we are also given an number of children which we have to distribute cookies. So let me just clear that. So suppose we have given cookies like 5, 4, 3, suppose 10 and 11, and so this bag so bag number 0 will contain 5 cookies, one will contain 4 cookies, second bag will contain 3 cookies, and yeah, so on. So what we can do is, and we also have a k number of children, so 1 2, yeah, k number of children. So in like, and yeah, we have to distribute these cookies to these k number of children. Like we have to distribute all cookies to these k children. So you like this, like you cannot. So if I have 5 cookies in a bag, so what is said in the problem is that we have to give all the cookies in each bag. So what I am trying to say is that from bag number 0, I cannot give 3 to this and 2 to this. We have to give all 5 to any children. Like we can give to 3, we can give to 4. So yeah, and like it is very obvious from the constraint that this is like a brute force kind of thing. Like you try all possible, like try all the solutions, and try to calculate the answer. So the constraint are from 2 to 8. So I think backtracking is the, like I found backtracking the best way to calculate answer. So let me just like let me just dig deeper for like explanation. So suppose we have 1, 2, 3, and 12. Then for this for this bag we have 5 candies, and like suppose we have suppose 3 children. So this bag of candies can given to this person, this children, or this children. And if we give back, and if we give this back to any of the children, then the candies will be added to his account. Like this 5 will be added to this 0% account, and we can give 4 to this, and then we can give 3 to this, then 10 to this, and 12 to this. We can also give 12 to this instead of giving this. So what I'm trying to say is that we have to try all the possible combinations of all the possible combinations, and you just have to calculate the uh, like you have to minimize the maximum of candies each person will get. So what that means is, suppose after distribution we have like candies. Suppose first person will get 10 and another one get 15, and suppose it get 9. So the maximum value is 15. So for this, suppose this answer is calculated from for like for any arrangement, this answer will come. So definitely this answer is not of this value. So this answer is like I have taken for explanation purposes. So suppose we have come to this answer for we do not care about from where we have come. Suppose the final answer in which the first, suppose the zeroth children will get 10 candies, first will get 15, second get 9. So the answer for this is 15, and then we have many arrangement for which, suppose here is 16, then 1, then 10. So what we have to calculate is these all these are the possible arrangement, and we have to calculate the minimum of this arrangement and this arrangement. So answer of this arrangement and answer of this arrangement. So answer of this arrangement is maximum value of, and answer of this arrangement is also the maximum value. And upon so our final answer will be minimum of first arrangement and arrangement 1 comma arrangement 2. So yeah, so let me just show you my code. So in the code I have initialized for k children, initially we have 0 candies, and answer I had initialized int max. So basically we have to minimize answer, so I have initialized to int max, and then I have this function backtrack. So it has a cookie vector which is given k, the number of children we have, and int of I represent so here int of I represent, suppose we have, so we are at bag I, and we have to give this bag to any of the children. So yeah, so we can give this bag to any of the k children. So if we give this bag to j children, then its cookie will get plus by this amount, and then we just again backtrack and take n is equals to 1. And if we do not give this number of cookie to this to j person, then we just get subtract, and we also have taken. So the base condition is if I is equals to cookie dot size, if we have reached so if we have reached here, so if we have taken all the bags, suppose, so suppose we are in this case the taken is 2, so we have to take all the bag. So if taken is equals to cookie dot size, then I just had calculated minimum of answer and maximum of for this for this array, for this arrangement I have calculated maximum, and then answer will be minimum of all the possible array. this is the explanation for fair distribution of cookies. And yeah, so and the last problem is naming a company. So in this problem, what we are given is in this problem we are given a like we are given an array of string ideas, and uh, in the process of in this problem we have to name a company, and the process of naming a company is as follow. Suppose we will choose two distinct ideas and call them idea A and idea B, and we just swap the first letter. And if the like the both names, the new names are not in the this array, then we just concatenate ideas 1 and idea B separated by a space, and this will be like a valid new name. So like I have to find the number of distinct valid names for a company. So what I'm trying to say is that suppose we have like our name array, or like our idea array as coffee, donuts, time, and toffee. So how the naming is done is that we can replace this. Okay, I cannot copy this. So what how the naming is done? Suppose I have our first name as coffee and another one as donuts. Donuts. So how is the naming for company is done? We will replace C with D and this D with C. So we will swap these two values. Like first we will swap this with this. Zeroth index of each name we will swap with any of like other names. So if the new name here will be Doffy, and here it will be Conuts, and this array will be like can consist of more elements. And if both of these elements are not in this like array, then Doffy space coffee will be a valid answer. So this will be an answer. So yeah. So the solution of this problem will be okay. So like what we can do is like we can replace, so like for brute force approach, like we can have like a n square solution. Like for this we will uh, try to replace, like suppose we will check if coffee uh, can make a valid name with this, and then with this, then with this. So this will take like a of n square time, and yeah, this will definitely exceed the time limit. And yeah, let me just tell you, the time limit in this problem is like very strict. So yeah, I got 5 penalties. So so we can replace this. So what we can more smartly do is, so we can replace this C with like with any of character from A to Z. Yeah, so we can replace this C with any of the Z. So suppose we have replaced C with D, and then what we can say is then we just calculate the answer. So suppose I have, so let me just more explain. So what I'm trying to say is, suppose we have C at the zeroth end, x of any string. So the all the possible values for like for what for what value we can replace c. So c can be replaced by any of the letter from a to z, or like you can more optimize this, so you can replace this a to replace this c with any of the first character, so like d, t and d. So yeah, so in worst case you can replace this c with uh, any of this a to z character. What what we can like how we can use this information to get to our answer. So we can say that if our first character is c and we had replaced it with any of the character from a to z, suppose we have replaced it with d, we have replaced it with d, and the new and the new d, like the new string that is formed by replacing c with d, is suppose y, and y is not in our current array. So like y is not found in our this like this ideas array. Then what we can do is, so we can take like a matrix like an 2D array, 2D array of size 26 into 26, and what is like, so like matrix I comma j basically represent, so here matrix of I comma j basically represent, if I have suppose I have character c, then I will take like c as a. Yeah. So if I have initial value c, so then I will be R2, and so yeah, so like this is a very basic conversion. Uh, so matrix of I comma j represent is, suppose we have replaced c with a, and it is not found in our array. So like the suppose we have cat, and we will replace this with a8d, and this is not found in our array. So AAD is not found in an array. Then what we can do is, uh, I comma j we can do is plus plus, and like how we can calculate the answer. Okay, so I have like as some no. So yeah, sorry, I have just messed up something. Sorry. So yeah, so matrix of I comma j is, we have replaced c with a, then I will be 2 and a will be 0. Then uh, we just have to calculate, like if we are at word donut and we are replacing d with c, then there will be definitely so how can, so for replacing d we can replace it to any of character from A to Z, and if we replace D with C, then answer will be only possible if there is some string that start with C and replacing its first letter with D does not get found in this array. So what I'm trying to say is that suppose we have A B C and D A B. So if we replace A with D, then the new word will form, and if this word is not in this array, then the answer will be plus plus. And what I'm trying to say is, if I had replaced this D with any of the character and this word is not found, then there will definitely, then the answer can only be possible when there is some word that start with the C and we have replaced it with D and it will not be founded in the array. So like this is like a confusing part. Suppose uh, we have replaced A with D and this word is not found in like in the array, and then we had encountered a word that start with B and I had replaced it with A, then all of the word that start with A get added to our answer. So what I'm trying to say is, suppose we have A, B, C, suppose B, C, D, and A, B, B. So B, C, C. So if we replace this, we can replace it from A to Z, and we had replaced it to suppose B, and this word is not found in this array. BB is not in this array. Then what we can do is we can increase matrix of I comma J. So basically A of A and B. So yeah, this will be, we can increase this value plus plus. So what we can do is this value plus plus, and what I have is this can only get answer if we replace this with A. So yeah, this is quite confusing. So in this map I have taken like if ideas like that we have like hash for all these values unordered hash, and then I have also calculated the first index like C D T D. So yeah, and then I just iterate of all over the idea of size, and then I had just replaced it with all, like I tried to replace it with all the first character. So then I have modified it. So yeah, I had stored the first index. So I had, suppose for D I had stored the D character at F, and then I just try to modify this with all the first values like C, D, T. So I had modified this, and if this is not found in our uh, have, so like we have all these. So if it is not found is, then answer. So answer will be the, so in this matrix. So what does this mean? So MP of I comma J means is uh, means the matrix, the suppose number words in which I have replaced like I character, I character with J character, and it is not found and not found in our in average. So this is the information stored is empty of I of j. So answer will be like the reverse of this. The number of word which start with J and whose first character is I. So I have plus the answer, and then I have done like I comma j plus plus, and the answer will be twice of the calculated amount. So what I am trying to say is, suppose ABC and DBC form a valid word, then DBC comma ABC will also form a valid word. So that's why I have answer plus answer. Yeah, that's for it.